All right, so we're going to begin Module 2, Lesson 12 today. We are going to be talking a little bit about the metric system. So I've given you guys one of these at your desk. We're going to be filling in just the top one together, dealing with length today, because we might see conversions when we're talking about decimal fractions. So we all have this on our desk, and again, we're just looking at our length one. If you flip it open and kind of take a peek at it. When you see these come up, please fill them in. It could be like almost a little cheat sheet for you while you're working on Zearn, making these conversions a little quicker, and removing the option of having to do a whole bunch of multiplication as you're working on some problems. I won't be giving you them all. Can I get a volunteer to read our learning target for Lesson 12 today? Go ahead and back for me. I had so many volunteers. Thank you.
I can reason about the product of a whole number and a decimal with constant using place value, understanding, and estimation.
Ooh, I'm going to pull up our projector so we can talk about this. What is different about this learning target? Can anyone pinpoint that detail? Go ahead again for me.
We're using hundreds.
We're using hundreds. Thank you for catching that, Cheyenne. Last time we were using tenths. So now we're looking at the hundreds place value. The biggest change here, not only are we adding another digit into a place value, so we would be looking at a two-digit decimal, right? We're also renaming using the hundredths place this time. Other than that, this is the same stuff we've been working on for most of Module 2. Do we have a question back here?
No.
Okay. So as we get started,
Yeah. Are we working on lesson 12
we are beginning Lesson 12.
today?
Today, we should. We're just going to go through a couple fluency problems. Then I'll model a couple with you guys under the document camera. And then we will get started on our practice problems independently with support from your teacher as needed, okay? So we'll get through this together, and then we'll move on. If you have an expo marker at your desk, you can participate with the backs of your binders. You can write on them, and I'll give you a disinfectant wipe after math so you can erase it properly. But you can jump right in and participate with me. I do. I have them stashed away. We've got plenty of disinfectant wipes. Thank you for being concerned. So we're going to jump into our fluency unit conversion. As we're doing this, I just want us to be mindful. We do have our foldable that we could be filling in just some information. We might not get to it all, but we want to have what we need, and we'll continue to fill this out as our metrics develop over time. 12 inches is equal to how many feet? Yell it out for me.
1.
Thank you. We can fill that one in the back, the opposite version. 1 foot is equal to 12 inches on your foldable. 24 inches is equal to how many feet?
2 feet.
2 feet, thank
1
you.
yard is equal to 3 feet.
36 inches is equal to
A yard. 3 feet.
3 feet, also equal to, let's do equal, not approximate, 1 yard. You can also fill that one in, right? So 3 feet. 48 inches is equal to how many feet? Yell it out for me. I want to hear voices. 4. We've got a pattern here. We see it unfolding, so we're now jumping quite a bit. 120. Who can divide 120 by 12?
5?
5? Are we sure?
12 feet.
12 feet?
Good. 12?
I think that's it.
What about 1 mile?
1 mile. We will touch on 1 mile. Cheyenne knows it. What is it?
I know what
It's 5,280 feet.
5,280 feet is equal to 1 mile. Thank you, Cheyenne. So you can fill that in on your foldable just as a cheat sheet for your metrics, okay? Go ahead, fill that in. We'll continue to fill this in over time when we touch on these other ones like mass and liquid volume, which happen later on in our 4th and 5th grade curriculum. Yes, Bud, what's your question on 9?
I don't have a whiteboard, a dry erase marker.
Oh, that's okay, Reed. Thank you for letting me know. You can just participate verbally if you want to shout out answers for me.
Okay.
Thank you. Can we have our voice off in the back corner when our peers are asking questions?
You just turned around and asked me what of mine.
Okay, so we are currently not accepting the feedback to find a level 0 voice. We accept feedback by saying okay.
Okay.
Thank you, guys. We are going to move on to our next slide, practice a little bit more of this fluency stuff. We're now looking at our decimals to add an additional layer of challenge. This is going to be more closely related to what you guys are doing on your assignment today for independent practice. The first one says 2 feet is equal to how many inches? That's a pretty quick one. 2 times 12.
2 times
24, thank you. Sorry, I didn't hear you the first time. 2.5 feet is equal to how many inches?
1 ton is 2,000 pounds.
Guys, let's go in order for me, please. So 2.5 feet is equal to how many inches?
That's 2 feet 12 inches.
So we're looking at inches, so we can add a half a foot to this response. How many inches are in a half a foot? 6. So 6 plus 24. 30. We didn't even have to do any multiplication. So we can use prior knowledge to come to quicker conversions if you can create those or draw those connections yourself. We're going to move on to 3 feet is equal to how many inches?
Oh, 3 feet? Oh, yeah, sorry. It is
36 inches.
36.
Thanks, guys. You can just shout it out. We rarely have opportunities to use just our voices without raising hands. So jump in. The quicker we get through this, the quicker you can start your independent practice. So 3.5, you can show me on your binder if you're quick. 42, 3.5 is equal to 42.
Everybody's saying that, so I said it.
Okay, we're going to test it because I don't see anyone super confident. 3.5 times 12.
That's 42. 3.5.
Thanks, guys. 42. You guys are doing this multiplication quick in your head. Thank you. Let's keep going. 4 feet is equal to how many inches? We've done this one
4 feet
already.
is equal to
48.
48. Thank you.
Why is everybody so much faster than me?
They're faster than me, even. 4.5 is equal to how many inches?
4.5 is 4.
Add 6 on.
No.
54. 54. 54.
Sounds like you guys are adding 8 on. Try adding just 6 to 48.
52.
52 inches. Thank you. So let's look.
No, it should be 54 because
54. You're right. You're right. Thanks, guys. Okay, 9 feet equals how many inches? 9 times 12.
9.
oh, that is
108 inches.
108.
Thanks. You guys are flying through these. Okay, 9.5.
Do we add a 6 or an 8?
We add a 6. Half a foot.
112.
100.
No, not 112.
114.
114. I heard it twice. I'm trusting it. There we go. Getting big now. 27 is equal to how many inches? 27 feet.
I can't do that in my head.
This is where I get stupid.
You guys have your binders to work it out. You can do a multiplication, a vertical strategy, and solve.
My thing is dry because it's not meant to be written on paper.
Your thing is dry because you were touching it on a tissue and you've been doing it quite a bit. So that's just kind of a natural consequence to misusing our dry erase markers. 27 times 12. That's what we're looking at.
Doing it right
That's
now.
324.
Thank you. So I'm well into it, so I'm going to finish it, but I believe you're correct, Cheyenne. $329 inches. Thank you. Last one. 27.5 feet equals how many inches?
I got 324.
24? Oh, you're right. Look at, where did I get that 9?
You added 0. You added 0.
Put a 0. Maybe that's what that problem.
Okay. So adding a half a foot onto our response, what is 27.5?
That's like 310.
310?
No, 330.
30. Thank you. 330. Okay. So that kind of wraps up our fluency. That's what we're going to be kind of doing with our theme. I'm going to turn our attention to our document camera now, where we'll be able to work out a couple of these. I'm going to start from number 1. Of course, I challenge you guys to work at your own pace and work ahead if you'd like to, or stick with my pace and see how we solve some of these together before you start on your own. So let me switch over my tech. You can go ahead and find your problem set 12 in your binder while I get my document camera ready. That's okay, you can keep my pace. I might move a little bit slower. Lesson 12, problem set.
Can I say what, how many pounds a ton is equal to?
No, we'll do that later on, Jackson, when we talk about weight. Let me grab a pencil for math. We know pencils work best with math since we can erase. Go ahead and find a pencil if you're using a pen to write.
Why not get kicked out of the meeting?
Oh, I didn't do it, Jackson, so I'm not sure why you got kicked out. I also lost my view in the Google Meet, so give me a second to find everyone. So we're now beginning our problem set. I'm going to switch my view so I have you guys over here. Are you seeing, can I get a thumbs up from my online friends if you can see our document camera okay for now? Thank you. Can you mute for me? Okay. So we are drawing our attention back to our worksheet. This is really similar to what we saw for lesson 11 and 10 even. You are going to be doing an area model, estimating, and then finding our precise answer. Give me just a minute to get this focused. There it is. Okay, I'll move around to make sure you guys have a good view, but I might block your view from time to time. But trust me, I'll move pretty quickly. So we are first going to be rounding since we're working on an estimation.
Oh, wait. Like estimation is like what the closest to?
Yep.
Oh, did I?
Right. See, this looks familiar. So you're going to estimate each individual digit before multiplying and finding the product, and then you'll use the standard algorithm to bring back in that decimal. So 1 and 21/100ths, that's closer to a whole number. 1 times 10. So that's what we would write on these lines here, our estimated whole numbers. 1 times 10 equals 10. Okay, and then we're going to look at our area model before we do our standard algorithm. Area model is where you demonstrate where that rounding occurred. So it looks similar to this we're setting up. We've got 1 plus 0. So on the side we have our whole digit 1. And then we have our decimal fraction, 21/100ths. On the top, we're going to do 10 plus 4. That's our area model. It just demonstrates where we rounded and still pulling those. We are at a level 0 voice, and the matter of your joke was not appropriate, okay? We got to take that a little bit more seriously. Thanks for accepting that feedback. So now we're going to go ahead with our standard algorithm. This is where we multiply our 2 bottom digits by each place value on top. Adding your place value holder before you go to your second digit. Adding. And last, right now we are looking at hundreds. If we are going to rename our product, we would say 1,694 hundredths. That indicates we have a decimal fraction. We can then bring back in our decimal by carrying it straight down. Our actual answer, precise answer, is 16 and 94 hundredths. Was our estimate reasonable? Is 10 close enough to 16? It's pretty close, maybe a bit off. Remember when we have 4 and down, or we would round down, 5 and up, we would round up. So it is just a little bit off. I'd say our reasonableness, or we might be a little bit unreasonable with our rounding here. Nice. I'm going to come around and look at responses on your page. Online kiddos, how are we doing following along with the document camera? You can give me a thumbs up.
Page, do we just round?
Hold on, I'm talking to our PV Connect friends. I see a thumbs up from 1 of 2. Thank you. Okay, I'm going to move around the room real quick to take a look at your guys' work. If you have individual questions, now's the time.
You just round this or when you need to.
So we're doing exactly what you see up there. We need the estimated product, we need the precise product, and we need our area model.
Wait, I need any area model on this?
Yep, this is use a separate piece of paper.
If it helps you though.
Okay, if it helps you. So you can skip the area model, but I do want precise and rounded products.
Okay.
I do want to give you the feedback. I've asked everyone to switch to pencil for math. Then you can just go ahead and do that as well. Nice, you guys are flying far ahead of me on the second page already.
What
Nice.
is the name?
Whoa, everyone's on the second page already.
Yeah, I did not know what to do.
Okay. So we are going to turn our attention to the front. If you want to see.
The second page is actually easier to the
Okay. So after roaming the room, we see everyone's worked their way to the second page. I am going to model how we would solve number 2A. It says estimate. We also can see our equal sign is not quite like the typical equal sign, indicating we are rounding. Then solve with the standard algorithm. So our decimal is going to be 1 and 23/100ths. We will round that to a whole number, which would be 2, or 1 in this case. We're still working with 1. And then we're looking at our whole digit, which is 12. We would also round that down to 10, just like we did with 1A. 1 times 10 equals 10. Thank you. Okay, now we're going to use our standard algorithm to get our precise product. So we stack them vertically. And we begin multiplying our bottom 2 digits by every place value on top. When you move to your second digit, don't forget your place value holder in the ones place. Adding. So we have 1,476 hundredths. That is renaming our units. We can bring down our decimal to know our answer is 14 and 76 hundredths. It says use a separate sheet of paper to answer using an area model if it helps you. So that's optional. The area model is something we see a lot with Zern. Not so much with our classwork, so that choice is yours if you want to use your area model. It is not for this part of the worksheet. Number 2A through 2H does not need you to do the area model unless it helps you. So for the remainder of our math time, which is about, we've got quite a bit. We're moving on math time really well. So we are going to spend the next 25 minutes working independently. And I will come around and answer questions as needed.